Right? So we're trying to find ultimately the reactions at E and the reactions at A. So again, there's going to be 4 external reactions, so it's statically indeterminate. We need to go down to the component level to do the analysis. Right? So it doesn't matter where we start. So I'll just start alphabetically for that reason only. So I'll draw member ABC first. So ABC has no external forces acting on it. But what forces and or couples do act on ABC? Right, so the normal force at A, we're ignoring friction, so there's just going to be a vertical force we can name AY. Right, at point B, we're interacting with one other member, so we can model that just as a pin type of connection with a horizontal and a vertical component. I will assume BX right, BY up, but if you make any other assumption, that's also fine, but you just have to remember for those internal ones, where we see it again, it has to be in equal and opposite directions. Right, and then C, it's pinned to one other member. So again, we can say it's CX and a CY. I'll assume CX right, CY up. So looking at this first free body diagram, I see I have 5 unknowns in it. So I'm actually going to, I'm not going to write the equations yet. I'm going to jump to my next free body diagram, since I know that I can't get all of the answers out of this one. So again, just going alphabetically, I can look at BD next. So I have one external, that's 0.6. One external force at the extreme left of 600 newtons. And then what else is affecting member BD? Yeah.
BX and BY in the opposite direction.
Right, so I already made the assumption of direction, so I'm obligated in this picture to draw it equal and opposite directions. So that choice is, I already made the choice up front, so this has to be this way. Yeah.
And therefore is perpendicular to CD at B.
Right, so we have that peg and slot type of connection there. So the member can move along the axis of CDE, but it's prevented from moving normal to that axis. So there's going to be a force. I'm going to make the assumption it's up and to the right here, although it's very possible it's down and to the left. I know it has to be, though, perpendicular to this line. So if this line is making a 3, 4, 5 triangle, with 3 as the base, 4 as the height, then this force must be the complement to that, which would be 4 as the base and 3 as the height. Right? So again, this is, it doesn't look like it, but this is perpendicular to that CDE axis. So I know the direction, but it could be up and right or it could be down and left, and we can let the equations tell us which it is. Before I get to that, any questions on the second free body diagram that we drew? So looking at this one, there's only 3 unknowns, so I'm actually going to jump to the equation step and get what those unknowns are at this point, and then go and write more equations as I need them. So from free body diagram number 2, I can get the value of D if I took sum of moments around B. So the value of D turns out to be actually, my assumption, the way I drew it was wrong. It's actually negative 500, which is okay, because it could be up and right or down and left. It doesn't have to be a positive value. According to the assumptions I made, BX is a negative 400, and BY is a negative 900. But BX and BY are also allowed to be negative values, so that's fine. If I go back now to my first free body diagram, I'm only left with 3 unknowns, so I can solve for those unknowns at this point. AY has to be positive, and it is, 183 newtons. I can get CX to be positive 400, And CY, I get, there it is, 717. But yeah, what am I asked to find? I did the reactions at A and at E. So far, I only have those at A. E did not even appear in A in my pictures, so I still do have to go and draw another picture because I need a picture that has E in it. So I still have one member that I didn't use yet, so I'm going to go and draw that member. So no external forces are acting on this. At C, I've already made the assumption of direction, so I have to draw it CX left, CY down. At D, I've also already made that assumption of direction, so I have to draw it in the opposite that I drew it in picture number 2. So the only choice I have left is at E. It's built into the ground, so I'll have an EY and an EX, and there'll be a couple that I will call M sub E acting at E as well. So from these steps, I know D, I know CY, I know CX. So I can find my 3 remaining unknowns now. So if I take the sum of moments around E, I can find M sub E. So that's going to be a negative 500 Newton meters according to my assumptions. EY, I get to be 417 newtons. And EX, I actually get 0.